Hello guys, welcome to Pepcoding, and now we are going to discuss the next question, that is all single child parent in a binary tree. Okay, so what we have to do in this question is given a binary tree, we have been given a binary tree, and what we have to return? We have to return a list of single child parent. What does that mean? Okay, a parent node which is having only one child. Okay, suppose this is 12 and this is 10. So in this, a single child parent is this node. So what we have to do, we have to traverse a tree and we have to fill all the single child parent node in a list, and in the end we have to return this list. Okay, so let's go and discuss this question. What actually we have to do. Okay, so let's go and see this. So this tree, we have been given the tree. Suppose this is a tree and this is a root. Okay, so what we have to do, we have to fill all the single child. So this node is having two child, so this is not a single child parent. Okay, so let's see this. So is this a single child parent node? No, this is also not a single child parent node, because it is having this node is having two childs. So this is not also this is also not possible. Okay, so is this a single child parent node? No, this is also not a single child parent node. Why? Because this is a leaf node. This node doesn't have any child, so it has zero child, so it is also not a parent node. Okay, so let's come here. So is this a single child parent node? Yes. Why? Because it has one child, which is 80, and in the right child it is null. Okay, so that's why it is a single child parent. Okay, so let me highlight this. So this is our answer. Okay, so what we have to do, we have to fill the list. Suppose this is our list. In this we have to insert 60. Okay, so let's move here. So is this a single child parent node? No, because this is a leaf node. So now we are going to move there. So is this a single child parent node? Yes. Why? Because it has one child only, that is 70, and the right child is null. So this will also be our answer. So what we have to do, we have to fill in the list. Okay, then let's move further. So is this a single child parent node? Yes, it is also having only one child, that is 100. Okay, so this will also be a single child parent. So let's move it further and let me insert it in list also. Okay, so is this a single child parent node? No, because this is a leaf node, so it is not also not possible. Okay, so in the end we have to return this list. So this is what exactly we have to do in this question. Okay, so how can we do this type of question? So I think you already having some idea, because we have already done in the level 1. Okay, so how can we do this? So first, what we have to do, we have to traverse it. Okay, so how can we traverse this? Simply we use one left call for node of left and node of right. Okay, so first I'm going to use the two recursive call, and in base case what we usually do, if node equal to null, that means we have to return. Okay, so this is what we do while traversing, but we have to do one more thing, that is we have to return it. When we have to return it? When we actually we have to handle one more case, that is we have to fill the node in the vector. So here I'm going to take a vector. Okay, so what we have to do is we have to fill all these node in a vector. So we have to handle this condition also, which is having a single child. Okay, so how we are going to handle this? So for this, what I'm going to do is I'm going to take one more condition here. So if the node is leaf node, then also I am going to return it. And how we are going to check the leaf node? If node dot left is null and node dot right is null, that means this is a leaf node. If both the condition is true, that means it is a leaf node. So in the leaf node also we are going to return it from here. Okay, and in the end I'm going to do one more condition. So let's go and code this, and in editor we are going to discuss this condition, and at the end what I'm going to do is I'm going to dry run this code. Okay, so let me erase this. And let's go and code this. Okay. So now I'm going to do the coding. So this is our snippet. So let's go here. So this is the list which we have to fill it. Okay. So what I'm going to do is I'm going to create one more method, that is fill single child parent. Okay. So this is our method, and in this function what I'm going to do, I'm going to pass root and answer. So I'm going to fill this list. Okay, so let me copy this and let's create this function, void, and now I have to receive these two parameters, tree node, let me give some name node, and the second one is vector int answer, and let me give the ampersand because we are going. Okay, so we have also received one vector and one node, and now I'm going to directly use the code for traversal. Okay, so what is the code for traversal? If node equal to null ptr, then in that case what we have to do, we have to return it. And then what I'm going to do, I'm going to give the left call as well as right call, node of left, and we also have to pass answer. Let me give for the right call also. Okay, so this code is for traversal. Now what we have to do is we have to handle one more case. See here, so this code is for leaf node. So if node of left is equal to null and node of right is equal to null, okay, so then in this case also we have to return it. And then I'm going to fill the array list, fill this array list in case of single child parent. Okay, so which condition I'm going to use? I'm going to use this condition. So first I'm going to write, then we will process this. Okay, so if node of left equal to null or node of right is equal to null, if any of this condition is true, then what we have to do? Then we have to fill our list. Okay, so for filling we simply use pushback. And what I'm going to push? I'm going to push the node of web. Okay, so this is how we are going to fill this in our vector. So why this is working? So when we are checking this, so we already know, we have already checked this condition that this is not a leaf node. Okay, when we are in this position, then in this case we already know that the node is not equal to null. Okay, and this is not a leaf node. This is not a leaf node. That means the left and right both are not equal to null. Okay, both together are not equal to null. Okay, that's why we are in this position now. If we are in this position, that means we have already checked this condition and this condition is false. So that's why these condition holds true. Okay, if we are in this position. So we already know that node is not equal to null and this is not a leaf node. So if any of condition is true, that means this is a single child parent node. Okay, so let's go and dry run this, and then I think we can better understand this. Okay, so let me take this code and just take it here, and now we are going to do the dry run. Okay, so let me shift it here. So this is our code. So let me take one stack. Why we are taking stack? Because we are doing the recursive code. So I'm going to take one stack. So this is our stack. Okay, so first we are going to call this root, that is 10, and all these conditions are false because this node is not equal to null, as well as this is not a leaf node. What does this mean? Leaf. Okay, so this is also not a leaf node. So now we are going to check this condition. So node of left is not null and right is also not null. So these both conditions are false. So now I'm going to call for the left. So now the code is going to be here. Now we are going to check for this node. Okay, so this node is a null. No, it is not a null, and this is also not a leaf node. So this condition are false. Now we are going to check this. So if any of left or right are null, no, left is also not null and right is also not null. So I'm going to again call for the left thing. Okay, so we are going to call 20 of left, then 90 will come. So node is equal to null. No, node is not equal to null. Is this condition holds true? Yes. The node of left is null, right is also equal to null. So both the conditions are true. That means this is the whole statement is true. So in this case, what we have to do? We have to return it. So 90 will wipe out from the stack. Now it is going to be here. So what I'm going to do? I'm going to call the right callers. Okay. Now the code is going to be here 60. So is this condition is true? No, because node is not equal to null. So is this condition is holds true? The node of right is equal to null, but node of left is not equal to null. That means this condition is false. Okay, because all the both condition doesn't hold true. So it is going to check for this. So if any of the node is null, then in that case we have to push it into the answer. Okay, so is node of left is equal to null? No, node of left is not equal to null. So I'm going to check for the right. So if node of right is equal to null? Yes, this condition holds true. So if any of the condition will hold true, it will enter in the if statement. So what I'm going to do? I'm going to add in the answer vector. So I'm going to add the node of val, that is 60. Okay, then I'm going to call for the left. So 80 will come. So it is a leaf node, so it is going to wipe out from the stack. Now I'm going to call for the right. So right is null, that means it is also going to be wiped out from the stack. Okay, so now I'm going to see this. So all the calls are finished, so it is also going to wipe out from the stack. Okay, so now what is going to happen? 10 of right. So we are going to reach in this position. Okay, so 40 will come into the stack. So is this a null? No, this is not a null. If the both condition holds true, no, it is not a leaf node also. So it is not going to run this. Okay, so it is going to check for the second statement. That is, if node of left is equal to null. No, the node of left is not equal to null. Is node of right is equal to null? Yes, this condition holds true. So what we have to do in this case? We have to push it into this list. Now I'm going to push 40 here. Now I'm going to for the left call. So 40 left call. Okay, so 70 is going to be here. Now I'm going to check for this. So is node is equal to null? No, node is not equal to null. node is also not equal to leaf node, then it is going to check for it. This is node of left is equal to null. Yes, this condition holds true. So what we have to do in this condition, in this case, we have to push the node of well. Okay, so 70 is going to be push. Okay, then what we have to do, we have to check for the next call. So left is, if I'm going to call for the left, so it is null, so it is going to return. Then I'm going to check for the right. I'm going to check for the right, that is 100. This is a leaf node, so it is also going to be returned. And we have completed all the calls, so it is also wipe out from the stack. Now it doesn't have any root, it doesn't have any node. So if we call the right, so it is actually null, so it is also going to be wiped out from the stack. And this is also going to be wiped out from this. Now our stack is empty, so we have used all the calls. So now let's go and run this and check whether our code is correct or not. So it is running successfully. So let me submit this, check for all the test cases. So all the test cases are running fine. So thank you guys for watching this video, and we'll meet you in the next video.